operations on sets, and we want to do a bit of extrapolation. We want to expound on the operation on sets. And number one, we are going to look on the union of sets. Union of sets. A union of sets. Let's say we have a set A, and again we have a set B. Set A and set B. A and B are two sets. The union of A, set A, denoted as A, U, B, U stands for the union, then is, let's say, assume set A has the following elements as 1, 5, and 7, and set B has got 8. This has to be curved brackets. Then the union of A and B, these are the elements that are both in A and that are both in set A and set B. So union of set A union B equals to 1, 5, 7, and 8. Okay, that's on the case of union, represented as, let's say this is A, then this is set B, then this is the union. Union is all elements that are both in A and B. Another operation is intersection of sets. Intersection of sets. By saying intersection, we mean those elements of the set that are in both sets. For example, let's say we have denoted for intersection is n. Let's say we have a set A to be 1, to be 5 and 6. Set B to be 6. Then A intersection B is those elements that are both in A and B. One, that this is 5 is not in A, is in A but not in B. So it is not an intersection. Intersection 6 is both in A and B, so equals to 6. The intersection of AB of set A and B is 6. Also can be represented in the grammatic manner. Then we'll be having those elements that are common. That is 6 is here. Our 6, then we have set A and B. So 6 is the one which is common in between in our set. Yeah. Then we have another operation on set, another unique operation. But what if, before we go to another operation, what if we have the first example? What if the intersection of A being 1, 5, this ought to be in comma form, then 1, 5, 7, then and B to be 8. What is the intersection of A, B, set A and B? The intersection, those elements which are common in A and B are empty. It has to be empty, are none. Then we move further to operation 3, that is complementary, the complement of a set. And in this, we have two unique parts. We have part 1, when an element is absolutely complement, is absolute complement. By saying absolute complement, suppose we say we have a universal set denoted as U, a universal set of elements, let's say R, A, E, O, and O. Then we have also A, or we have B to be the only set in the universal set, in the universal set denoted as U. Then we say of course, we say that the absolute denoted as this way, complement, or absolute complement, and in sets we denote the absolute complement as B raised to power C, or B, then we have some negative on the upper side, which is then assume we have set B to be A, E, and O. Then the absolute complement of B is equal to U, because absolute complement of B, absolute complement, these are elements that are in U. They are elements, not they are elements, absolute complement elements in B, in U, but not take a note point there, not in B, in set B. Then we also have another significant case of complement. Then that is we have got relative complement. Suppose we have for example, we have a set A, and again we have a set B. The relative complement of set A to B, these are elements, not elements. They are elements in A, in set A, but not in B, not in set B. For example, we can say we can have set A to be 1, 7, and 10, and set B to be, then set B we have 7 and 10. The relative complement of A denoted as A minus B equals to 1. Then remember, if you write 1 without having it held within or encased within the curved bracket, then still you will score 0 in your exam or in your assignment. Thanks for watching. Bye bye.